For this sheet, we're going to count how many different elements we see in these 10 compounds, and then how many atoms total there are to make these various molecules. So this first compound, we have H2SO4. That is sulfuric acid. That's the acid that you find in batteries. So to determine the different elements, all we have to do is count the capital letters that we see, because remember, that represents the elements on the periodic table. So we have 1, 2, 3 capital letters: hydrogen, sulfur, and oxygen. So there's 3 different elements involved in this compound. And then to count the number of atoms, we have 2 hydrogens. We haven't understood 1 for this sulfur, so 1 sulfur. And we have 4 oxygens. And when we add them up, 2 plus 1 plus 4 gives us a total of 7 atoms. For this next one, we have C12H22O11. That is sucrose. That is common table sugar. How many different elements do we have? Again, count the capital letters. Carbon plus hydrogen plus oxygen gives us 3 capital letters, 3 different elements. We're going to take and add up our little numbers. Remember what those are called? Subscripts. So 12 plus 22 plus 11. And 12 plus 22 is 34, plus 11 is 45. So 45 different atoms to make that molecule of sucrose. In our notes, we did another sugar molecule called glucose, C6H12O6. Okay, this chemical compound is calcium hydroxide, CaOH, parentheses 2. The OH is the hydroxide. How many different elements are there? Count the capital letters. 1, 2, 3. Calcium, oxygen, and hydrogen. In the next unit, you're going to have to learn these elements' names and symbols, so we want to make sure we're practicing them now. Now, how many atoms total? This one gets interesting because we have the parentheses, and the parentheses applies to the elements that are within the parentheses. So we have to distribute the number behind it. This 2 belongs to both the hydrogen and the oxygen. There's no number back here, so we have an understood 1 for both the hydrogen, the oxygen, and while we are at it, we also have an understood 1 for the calcium. So 2 times 1 for the hydrogen gives us 2 hydrogens. 2 times the understood 1 for the oxygen gives us 2 oxygens. And then the 2 does not belong to the calcium because the calcium is not in the parentheses. So there is just 1 calcium. When we add these up, 1 plus 2 plus 2 gives us 5 atoms total. Now this next one is so easy that some of you were asking me about it, trying to make it harder than it is. KOH, remember OH from up here, is called what? Remember, it's called hydroxide. So this OH is hydroxide as well, but who is K? Remember, it is potassium. So KOH is potassium hydroxide. And we have 1, 2, 3 capital letters. And everybody here has an understood 1. Everybody there has an understood 1. So just like there are 3 different elements, there's 3 atoms to make that. Now for this next one, MgNO3(2). This is magnesium nitrate. We count the capital letters, 1, 2, 3. So there's 3 different elements involved, but we've got to figure out the atoms. This 2 belongs not only to the oxygen, but also to the nitrogen here. So 2 times 3 is 6. It's like we have to distribute it, just like we would in math. And 2 times, remember there's an understood 1 there, 2 times 1 gives me 2 nitrogens. Does this 2 get multiplied by the magnesium? No, it does not, because the magnesium is not in the parentheses, and there's just an understood 1 right here for the magnesium, so it's just 1 magnesium. So we add it up. 1 plus 2 is 3, and 3 plus 6 is 9. So that has 9 atoms total in that molecule of magnesium nitrate. Okay? Number 6. This is a cool compound. H2O2 is very similar to water, except it has an extra oxygen. So H2O2 is actually hydrogen peroxide. The stuff kind of in the medicines around Band-Aids. Hydrogen peroxide is the bubbly stuff that you would pour on a cut. Makes extra oxygen. So how many different elements are there? There's 2. 1, 2, hydrogen and oxygen. We do not count the number out in front. We only count the capital letters. Now, how many atoms total? This is where it's going to get a little interesting because we have a big coefficient out in front. But the first thing we're going to do is take care of just the compound itself. So we have 2 hydrogens and 2 oxygens, which give us 4 total for 1 molecule of H2O2. So then, once we know that 1 molecule has 4, I'm going to take and multiply that by the number out in front times 2, and that's going to give me 8 atoms total. If the big number out in front were 3, then I would multiply it by 3, and 4 times 3 would give me 12 for the atoms total. That's how we handle coefficients, the big numbers out in front. Okay, this next compound right here, you had on a bell ringer a few days back. This is ethane, a type of gas. Methane is CH4, ethane is C2H6. So how many different elements are there? Carbon and hydrogen. So there's just 2. There's 2 carbons plus 6 hydrogens, which give us 8 atoms total. But we have this big number 6 out in front. So 8 times 6, remember those times tables, is going to give me 48 atoms total. So far, that's our biggest one if we were to build with our molecular model kits that you saw in the notes. Okay, this next one, Pb, remember that is lead, and this polyatomic ion is called perchlorate, so that is Cl right there. So lead perchlorate, when we count the different elements, we have 1 capital letter, Cl has 1 capital letter, and then oxygen. So there are 3 different elements for lead perchlorate. And now we have to count our atoms. So there's an understood 1 here for the chlorine and an understood 1 here for lead. So 2 times 4 is going to give me 8 oxygens. And 2 times that understood 1 is going to give me 2 for the chlorines. And the 2 does not get multiplied by the lead because lead is not in the parentheses. So there's just 1 lead. So 1 plus 2 is 3, plus 8 is going to be 11. So there's 11 atoms total for lead perchlorate, and there's 3 different elements involved. Next, we have what's called nitric acid, HNO3. We have a big coefficient of 5 out in the front that we've got to remember to deal with. But first, let's count the different elements. We have H, N, and O, so that's 3 different elements involved. We have an understood 1 here in front of the N, and an understood 1 here in front of the H. So when we add up our subscripts, 1 plus 1 plus 3 gives us 5, but we've got to remember this big 5 out in front to multiply by, which is going to give us 25 total. 5 times 5 is 25. 25 atoms total. And then our last one is H3PO4, which is called phosphoric acid. Acids start with H's. And for phosphoric acid, we have a coefficient of 2 out in front. When we count our different elements, we have hydrogen, phosphorus, and oxygen, 3 capital letters, so 3 different elements involved. Nobody's in parentheses, so that's a nice break from that, we do have a coefficient to deal with, and we have an understood 1 here for the phosphorus. So 3 hydrogens, 1 phosphorus, and 4 oxygens. When we add that up, we're going to get 8. And we have to remember to multiply times that coefficient of 2 out in front, and 8 times 2 is going to give me 16. Okay, so that's going to finish us up for this sheet. This skill is very important for you to be able to do in Unit 9 because it's going to come back in Unit 10 in you being able to balance chemical reactions to prove that the law of conservation of matter is happening. So if you have any questions about this, make sure that you let your teacher know.